Hello beautiful people and welcome. In today's video I will be going through your homework number 2. Just a reminder, I am human, so if I make a mistake, please let me know where the mistake occurs so that way I may learn from my mistakes. Alright, let's go ahead and get going. Question number 1, describe the transformations necessary to transform the graph of f of x into that of g of x. So when they're asking you to describe, they're asking you to use English, okay? So we're going to take a look at the parent function and we're going to take a look at the transformed function, and every single thing that is different needs a explanation, needs a description. So let's start off with the minus here, and I do the arrow method. Next, I have a 3. Notice that the 3 is separated from the negative. Then I have a plus here. Now notice I did not go inside of my square root, and the reason being is anytime you have something on the inside of your parentheses, of your function, of your square root, anything, that means that you have to factor out. So we are going to be factoring out 3x minus 12. Now when you factor out, the trick is you're going to be dividing by whatever is attached to x. So I'm going to be dividing by 3 and 3, meaning what I actually have is 3 open parentheses, x minus 4, close the parentheses. Now this is still inside of my function, so I'm going to still have this inside of a square root. So I don't even have a 12. This 12 doesn't exist. So what I instead have inside of the square root is I have a 3 open x minus 4. Now, for the English portion of this is where you need to have your graphic organizer memorized. When you have a negative on the outside, just the negative on the outside of your function, this is a reflection across the x-axis. 3 is a multiplier. 3 is outside of the square root. 3 is a vertical stretch by a factor of 3. Then we go inside of the function. Inside means opposite of what you have. So if I see a 3, that means I have a 1/3. And what that means is I have a horizontal compression by 1/3. Then I see this minus 4. That means I have a plus 4 opposite of what you see, meaning I'm going to go right 4. And lastly, we have this 8, and this 8 is a shift up by 8. I'm going to put this factor in a thinking bubble so we know it pertains to A. Next, moving on to B, again, similar, we have a function, x squared. Anything that is different from the x squared needs an explanation. Let's go ahead and start out. I have a 1/5 here, no negative on the outside. I do not have anything on the back side. And then here I do have an inside of that. So for B, we need to factor negative x minus 2, which means I'm going to take this. Here's a secret 1 that's in front of x, and I'm going to be dividing by that negative 1. So that means what I actually have is a negative 1 open x, negative 1 divided by, negative 2 divided by negative 1 is a positive 2. Close it. Now this is still inside. So if I have my parentheses here, here's my parentheses and here's my parentheses. Here are still my parentheses, and here's my squared on the outside. So although I am creating new parentheses, new bubbles, it's still inside of my function. So I don't have this negative 2. Instead, I have open, negative 1, open, x plus 2, close it, square it. Which means that I need to go in, and this negative 1 needs a descriptor. and this too needs a descriptor. So let's go ahead and start off. I see a 1/5 multiplier on the outside of my function. That means I have a vertical. Shrink or compression by 1/5. You remember, you have to tell me the multiplier. This negative, if you are uncomfortable with it being -1, like 1 is an actual number, you can just leave off that 1 and just write negative. That is okay as well, because if you see a number, it might trip you up. So if that bothers you, just leave it as a negative, which means that we have a reflection across the y-axis. For the 2, I see a +2. That means I have a -2. And that means I'm going to go left 2. This has nothing to do with the original -2. We don't have an original -2. It doesn't exist. Okay? Moving on to the next one. This one, I do see a negative on the outside. I do see a 1/5 on the inside, which again, anything that has anything to do with the inside, I'm going to highlight that, and I'm going to factor 1/5 x minus 2. Now if you are using a calculator, that's fine. You can also not use a calculator, that's okay as well. So if you are using a calculator, again, that is perfectly okay. We are going to be, just like I said before, dividing. Now, I mentioned the calculator a few times. You must have the 1/5 in parentheses if you are dividing using this method. Otherwise, it will give you a wrong answer. So for example, anytime you have a fraction, even this original 1/5, open 1/5, I made myself chuckle, divided by open 1/5 equals, and that should give you 1. So when we are factoring out that 1/5, open, I need -2 divided by open 1/5, close, enter. That means I have x, 1x, minus 25 left over. And I'm hesitating because I'm like, that's not 25, that's wrong. I'm very happy I caught myself on that. I'm like, that seems weird. Ladies and gentlemen, I made a mistake on my calculator. Do you see that? I typed in a -5. I don't have a -5. I have a -2. Let's fix that. That should be a -10. I'm very happy that I caught that. I hope you guys were screaming at the computer. All right, now, again, this is inside of my function, so I still have my absolute value here and here. So my absolute value is still present. So inside of my absolute value, I have my 1/5, open, x minus 10, close it. This 2 does not exist. And then I still do have that -1 on the outside. So let's go ahead and do our describing. I have a reflection across the x-axis. This 1/5 represents a vertical. Let's see. Let me go ahead and write that here, and I'll write in English off to the side. So I see a 1/5. That means I have, take its reciprocal, a 5. And if I have a 5, that means I have a horizontal, not a compression. This is a horizontal stretch by a factor of 5. Okay, be careful here. And then this -10 that I see, that means I have a +10, and that means I'm going to the right by 10. And then the last one that I have, this -1, that's just down 1. Okay, I'm going to quickly highlight that so it's a little bit. So we have a reflection across the x-axis. We have a horizontal stretch by 5. We have a right 10 and a down by 1. Please remember, if you have anything inside of a function that is required for you to factor that out. Okay, moving on. Use the description to write the transform function g of x. So we are now given something, and based off of what is given, we are writing the equation for that. Now they do want the equation in the form of g of x, so that's what we're going to call it in the end. Order does matter. So in class, I did ask you to use a table method. So in the table method, I have the original. So let's start there. Original is given to us as f of x. You can ignore f of x if you'd like. Then we are reflected across the x-axis. We are then stretched horizontally by a factor of 3 and translated 1 unit left and 4 units down. Okay, let's go ahead and do this step by step. I'm going to switch to pencil in case I need to erase. Space is limited here. Okay, so we have our original reflection by the x-axis. That means we're going to place a negative in front of our f of x. So what is our f of x? We're going to take our function and we're going to place it here. So a reflection across the x-axis would mean that our f of x, this f of x, is now transformed as the square root of x with a negative on the outside. I'm going to put this in a little thinking bubble. This is our new function we are dealing with. We're going to bring that to the next. Stretch horizontally by 3. That means we have 3. That means when I write it, I'm going to see the reciprocal of 1/3. So that means I have a function, and inside of it I have 1/3 x. Remember, if you have something on the inside of your function, you have to change out x. Just because we have multiple x's doesn't mean they're the same x's. So we have negative square root of x. I'm going to open up this x. This x right here that I'm writing does not exist anymore, and instead I'm going to be putting in that 1/3 x from my function. Putting that in a thinking bubble. This is my new function. I am writing it here. Left 1. Left means horizontal. So that means I have a 1. That means I should see a positive 1. Okay? Left means negative. That means we see a positive 1 in our function. So here's our function. X plus 1. Be careful here with the plus and the minus. That means I'm taking my function, negative square root of 1/3. I'm opening up for x. I apologize for it being so smushed. And inside of that x, I'm putting x plus 1. Be careful here. You do need to simplify. I'm going to leave it for the sake of space. Okay. Here's my thinking bubble. Here's my new function. And lastly, down, this is outside of your function. This is vertical. So that means I have my function of f of x, and I'm going to go down 4. That means this function right here, this thinking bubble, stays the same. It doesn't change. I'm going to keep it in factored form on the inside because of space. That -4 goes on the outside. Now this is my last step, so what am I calling it? I'm calling it g of x. Why am I calling it g of x? Because they told me to. They're asking us to write a new function, g of x, and that is my answer. Okay, moving on. B, same thing. We're going to create our table and take it one step at a time. So parent function, here's our original. I'm going to move things over just in case I need more space. All right, original function is f of x is equal to x squared. That's our parent function. It is vertically compressed by 1/2, reflected across the y-axis, and translated 2 units to the left. Okay, switching to pencil in case I make a mistake. We're going to take our function, vertical compression. Vertical is outside. So that means we don't need to flip anything. Here's our function. And I'm going to place that 1/2 as a multiplier on the outside. So what happens is I'm going to take this 1/2 and I'm going to replace f of x with it. And I think I said 1/2, which is incorrect. I'm going to take this x squared and I'm going to replace f of x with it. And I'm going to bring down the multiplier of 1/2. This here in this thinking bubble, this is my new function that's going to be brought up for step number 2. Reflected across the y, this is an inside. And when I am writing this, I'm writing a negative on the inside. Remember, anytime you have a change on the inside, you're going to open up your function. Here's my original x, and you're going to take the new x, whatever's in here, and you're going to write it inside, which is negative x, like that. Next, again, you can simplify this. We'll talk about that a little bit more in just a little bit. This is here your new function. We're going to bring that up, and we have a left. Left is inside. So that means what you actually have here, left means negative 2, and you're going to see a positive 2 in your function. Remember, left means negative. So in your function of this positive 2, you're having that inside. Remember, anything inside changes what you have, so 1/2. I still have that negative. I open up for x, and I still have my squared. So here inside, I'm going to be placing this x plus 2. And again, we are going to talk about simplifying this. This is my last step. To simplify this, we go back and revisit the world of IM2. And we can simplify by separating this out. Now, I'm going to show you here on a separate sheet of paper, and then I'll write down my simplified version on the actual sheet. So if I have 1/2, open, negative, open, x plus 2, close it, squared. This squared function, this is a secret 1 times, can be applied into my multiplication. It's a property that we have, a multiplying property. So what I really have is 1/2, open, negative 1 squared times x plus 2 squared, because I had this secret negative 1 on the outside. Now if I take a calculator and I have to type this in with parentheses, if not it will give me the wrong answer. If I take negative 1 and square it, it gives me a positive 1. So I actually have 1/2 times 1 times this x plus 2 squared. Here, 1/2 times 1 is 1/2. Open, x plus 2, close it, squared. This is my function of g of x. And I'm going to shift that up so you guys can see it a little bit better. I'm going to repeat the instructions, or I'm going to repeat the explanations. We had a 1/2 on the outside. Inside we had a negative. Well, I had a negative secret 1. You don't see this one, you just have a negative 1 here. Then I had an x plus 2. Both the negative 1 times and the x plus 2 are squared. So based off of a multiplicative property, we can separate them out only because I have times. If I didn't have this multiplication, this would be impossible. Next, I typed into my calculator negative 1 in parentheses squared. This gives me a positive 1. 1/2 times 1 is 1/2. This we cannot simplify. This gets brought down. So for question number 2b, our simplified version is 1/2. Open, x plus 2, close it, squared is equal to g of x. Okay, moving on. For question number 3, this is asking us to write a rule g of x described by the transformation graph of f. Okay, so this is where they're giving you an equation that has already been transformed, and they want you to continue transforming it. So just like we did previously, I am going to ask you to do a quick little table and start with a different original. We don't have a parent function, we already have a transform function. So original, and the original function is negative 5x plus 2. You can keep off the f of x in your work, that's okay too. Okay, the graph of f has been reflected across the x-axis, so reflect across x-axis. So that's our first change. Then shifted up by 3. Reflected across the x-axis is an outside change, so we're going to have a negative on the outside of f of x. Remember, what is f of x? Well, f of x is this function here that I'm just going to replace. So negative 5x plus 2. Careful here because we are reflecting across the x-axis, meaning we do have the negative outside of that function. Be careful here. You do need to, because this is a linear equation, not like 2a and 2b. In 3a, this is linear. The exponent is 1, so you need to simplify before moving on by distributing that negative. So what you actually have in this step here is 5x minus 2. Again, be careful. This is your temporary function. Bring that up. And, no pun intended, we have up, which is a vertical change. So that means I am going to have outside of my function a positive 3. Okay, so what is my function? Here you got to be careful because you're not using the original. You're using the first transformed. So my function now is 5x minus 2. And now I am shifting up 3. And again, because this is a linear function, only because it's linear, we do need to simplify. So what we really have is 5x minus 2 plus 3. So we have 5x plus 1. Again, what do they want it to be called? They want it to be called g of x. All right, let's go again. B. Here's our next one, original. I really should have given you a lot more space for this. I apologize for that. If you want to use a separate sheet of paper and attach that as part of your work, you are more than welcome to. Okay, original is absolute value of 6x, absolute value, so close the absolute value, minus 2. The graph of f has been reflected across the y-axis. And has horizontally compressed by 1/3. All right, let's go ahead and start. Reflection across the y-axis. This is an inside change. So here's my function. Inside of that, we're going to be changing. What that means is I am going to be taking my original function, this absolute value of 6, opening up the x, and inside of that, I'm putting this negative x. Okay, putting this in a thinking bubble. Yes, we can simplify that. I'll simplify that in the next step. We're just short on space here. Horizontal compression, again, inside. Horizontal means inside. That means this is what I have. I have a compression of 1/3. So that means what I'm going to see inside of my function is a 3. So what I have is f of 3x, which is going to be replaced the original x. So I am going to simplify this before I put the 3x in it, because I do have a little bit more space here. I can write things out. So I had absolute value of 6, open, negative x, close it, absolute value minus 2. This is from here. Okay, that got simplified to negative 6x minus 2. I'm then going to open up 4x, and I'm going to put in my compression of 1/3. Which then I'm going to simplify one more time, which gives me the absolute value of negative 18x, close it, minus 2. Okay, so just like we did before, There are some special multiplicative, that word is giving me a hard time today. There's some multiplication rules when it comes to having things squared and having things in an absolute value. So within an absolute value, you can simplify this further, not the -2, but inside. Let's go ahead and write this out. I am doing this in a separate sheet of paper just for space. We can separate out the absolute value as follows. I can put a -1 times 18x. Now each one of them has its own absolute value now. So in what I'm doing kind of like is factoring out that -1, but it's still inside an absolute value. So okay, so what is the absolute value of -1? The absolute value of -1 is just 1. So now we have 1 times the absolute value of 18x minus 2. 1 gets kind of ignored because it's just 1 multiplier, it doesn't change anything. So what we actually have for this question is positive 18x minus 2. So be careful. This negative needs to be simplified. So what we actually have, let's see if I can make it fit here, absolute value of 18x, absolute value, minus 2 is equal to g of x. This is your answer. Be careful. It is positive. Okay. Moving on to C. C kind of has a little bit more space. We'll see. No pun intended. Okay, so we have original, and the original is x squared minus 1. The graph has been vertically and horizontally compressed by 1/2. So be careful here. There's 2 steps in one. So vertical compression is 1/2 and horizontal compression good. And then it's shifted up by 3. Let's go ahead and start. Vertical is outside, so we have f of x. Compression, we keep it because it's vertical. On the outside, we have 1/2. Be careful here of what you're actually putting the 1/2 on. This function, this entire thing is x squared minus 1. So when I write my 1/2, I have to open up my function, which is x squared minus 1. Okay, then you can choose to simplify this now and bring the 1/2 in right now, or you can wait. It is up to you. I am going to move my parentheses a little bit closer so I have a little bit more space, and then I will choose to simplify that. So I'm going to bring in the 1/2 here and the 1/2 here. I'm not bringing it inside of the x. I'm not bringing it inside of that. I am distributing because I have parentheses. I have a binomial. So I have 1/2 x squared minus 1/2. This is the function that I'm going to be bringing in for step number 2. Now step number 2, horizontal compression is what I have. That means when I write my function, I'm going to see a 3, just kidding, a 2, a full 2. So what that means is inside of my function, I'm going to see I did a 3 again. I don't know why, maybe I'm looking at my up. This should be a 2. Because we are compressing by 1/2, I should see a 2, and I should have 2x inside of my function. Okay, so be careful here. Inside of my function means I'm taking my function, I'm going to open up for x, and I'm going to put in this 2x in here. Be careful here. You cannot multiply that 1/2 into 2x. Instead, again, I'm going to do this off to the side. Instead, what we have is 1/2 times 2x squared minus 1/2. Which means I have 1/2 times 2x times 2x minus 1/2, which means I have 1/2 times 4x squared minus 1/2. And now since I have 4 not inside of my x, or I guess inside the parentheses, the squared is only on x, the squared is no longer on 4, then I can multiply these 1/2 times 4 to simplify it. Which means 4 times 1/2, half of 4 is 2x squared minus 1/2 here. And again, I sincerely apologize for not giving you enough space. Use separate sheets of paper. All right, so that means my next function here is 2x squared minus 1/2. Thinking bubble around it, that's what we're going to be using in step number 3. In step number 3, we have a shifted up by 3. This is on the outside of my function, so outside f of x, outside up 3. So the entire function f of x is what we're going to be using in step number 3. 1, 2, 3, yeah. 2x squared minus 1/2. Then we got this plus 3 here. And now notice that I do have a negative 1/2 not attached to the x squared and plus 3. If you wish to use a calculator, that is fine. Or you can do this by hand of saying negative 1/2 plus 3, which is negative 1/2 plus, let's make this over 1. Common denominators, multiply by 2, multiply by 2, I get 6/2, which gives me 1 minus negative 1 plus 6, or 6 minus 1/2, which gives me a 5/2. So for my final answer, 2x squared plus 5/2 is equal to g of x. Okay, and again, my bad for not giving you enough space. Moving on. Question number 4 is asking you to solve systems that only have 2 variables. I am giving you 2, A and B. Let's go ahead and do that. On question 4A, we are already given a variable that matches, and that is x. That means you have to be careful on how you choose to remove this x. You got to check if you're going to be adding or if you're going to be subtracting. So I have 1x plus a negative 1, so that means I need to add. Now when you write this addition, please write it underneath each section, each term. So that means we have our x's are gone. 3 plus positive 2 is 5. 1 plus 4 is 5. Don't be shy about using a calculator, please, especially with positives and negatives. Go ahead and divide by 5 both sides. Y is then equal to 1. Put this in a thinking bubble because this is not your answer. You're going to pick one of the original equations. I usually choose the top one. So x plus 3y is equal to 1. I'm going to open up for y because that is what I have solved for. Y was equal to 1. I'm going to type this into the calculator if needed. X plus 3 times 1 is 3 equals 1. Subtract 3, dotted line for balance. X is then equal to a negative 2. Again, thinking bubble, this right here is not your answer. So what is the answer for A? We're going to open up parentheses. Parentheses are required. If you don't put your parentheses, it is going to be marked incomplete. We are solving for a point of intersection. A point has parentheses and a comma. Our x value was negative 2. Our y value was positive 1. This is the answer for A. Let's do this again in B. Now if you notice in B, the x's do not match and the y's do not match. We don't care about the 0 and 1. So it is up to you if you wish to eliminate x or if you wish to eliminate y. If you choose one or the other, you have to create matching coefficients. Plus and minus are okay. So I am going to multiply this by, I'm going to choose x, so I'm going to multiply this by 3, and each term gets a 3, meaning what I have here is 3x plus 3y equals 0. In my bottom equation, I have 3x plus 2y equals 1. Now, unlike A, here we have to be careful on whether or not we're going to be adding or subtracting to eliminate x. I have chosen x to eliminate, and if I do 3 plus, like we did in example A, 3 plus 3 is not 0. So adding 3 is not going to eliminate my x's. So instead, I now have to subtract. Now when I'm subtracting, I am going to subtract all of my terms. So subtraction here, here, and here. Please do not hesitate to use a calculator for your adding and subtracting. So I got 3 minus 3, that gives me 0, that goes away. 3 minus 2, that gives me a 1y. 0 minus 1 gives me a negative 1. Y is then equal to negative 1, thinking bubble, because this is not your answer. Pick one of the original equations. I usually choose the first one. First one unaltered is x plus y equals 0. I'm going to open up for y because that is what I solved for. I have x minus 1 equals 0, dotted line for balance, add 1 to both sides, and this is x is equal to 1. Again, this is not your answer. So therefore, what is our answer for B? Our answer for B must have parentheses, must have a comma, and then we're going to take our x value of 1 and our y value of negative 1. Alrighty. I'm going to go ahead and pause the video here. You won't notice it, but I am going to have to come back and continue recording for question number 5. Alrighty, and I am back. Question number 5, I did rewrite and already started with my highlighter. I am going to take my top two equations and I am going to write them out here. So x plus y plus z equals 2. 5x plus y, or 5y, excuse me, plus 5z is equal to 3. Okay? Now, in this step, I am going to choose to simplify one of the variables. So the variable I'm going to choose is I'm going to choose to eliminate x. When I choose to eliminate x, I notice that my x's do not match, so I'm going to be multiplying by 5. Now here you can choose to multiply by negative 5 as well to make them opposites. I don't do that. So we have 5x plus 5y plus 5z is equal to 2. Down below we still have our original 5x plus 5y plus 5z is equal to 3. And I did notice I did not multiply that 2, so let's go ahead and multiply that 2 by 5, and that gives me a 10 here. Hopefully you caught that. My goal is to eliminate x, that is the variable of my choosing. In order to eliminate x, I am going to subtract. Again, my focus is on the x's, not on any other variable. So I am going to subtract in order to eliminate my x's. So I'm going to do a little minus here, here, and here. Okay, dotted line for balance. We have 5 minus 5, which is 0 x's. That's gone. But here I also have 5 minus 5, which is 0 y's. And here 5 minus 5, which is 0 z's. 10 minus 3 is 7. Now, if you notice here, I do have nothing plus nothing plus nothing, which is 0. Dotted line represents an equals. And here I have 7. Does 0 equal 7? No, it does not. Since it does not equal 7, this is considered an always false statement. And since we have an always false statement, our answer to this question is no solution. Moving on. Our next equations are 6x plus 8y minus 6z equals 62, which immediately I'm going to take, and 10x minus 12y minus 14z equals 14, which again I'm going to take. Writing out the top two equations, I am doing a quick little mental check and seeing that all of these are even. Maybe I can simplify, but we shall see. And as I'm writing this out, I'm also doing a quick mental check as to what variable I am going to choose to eliminate. So I am going to choose to eliminate, let's choose y, because why not? It doesn't matter. So I'm going to choose to eliminate y's. Notice that they are not matching, plus and minus are okay. So I need to multiply this top one by 3 and this bottom one by 2 to get 24. So we end up having 3 times 6 is 18. 3 times 8 is 24. Y. 6 times 3 is 18. Z. Careful with that minus. And that, I will be honest, I don't know. 62 times 3 is 186. Now I'm also going to multiply the bottom one. So I get 20x minus 24y minus 28. Z is equal to 28. Next, my goal is to eliminate my y's. That is what I have chosen. So I am going to, in this case, add to remove my y's. Now again, please check with the calculator that indeed you are going to eliminate your variable of choosing. Draw a line, dotted line for balance. These go away. 18x plus 20x, that gives me a 38x. These are gone. Negative 18 plus a negative 28, that gives me a negative 46z. 186 plus 28 gives me 214. All of these are even. We can check if we can simplify, or you can keep it. It is up to you. I'm going to choose to keep it. I'm placing this in my first thinking bubble. Now I'm going to pick up my bottom two equations from the original given ones. We got 10x minus 12y minus 14z equals 14. 12x minus 8y plus 20z equals negative 68. Now, reminder, in step number 2, you no longer have a choice. In step number 1, it was my choice to eliminate y. In step number 2, I don't have a choice. I must eliminate y. And I'm noticing I have a 12 and an 8, so I do need to multiply both top and bottom equations in order to get them to match. So I'm going to multiply the top one by 2, and I'm going to multiply the bottom one by 3. I end up having 20x minus 24y minus 28z is equal to 28. On the bottom, I end up having 30. Is it 36? Why am I second guessing myself? Yeah, it's 36. X minus 24y plus 60z is equal to, so negative 68 times 3, I'm using a calculator here, 204. Okay. Next, my goal, my objective is to eliminate my y's. Now, here's where you need to be careful. If I choose to add like I did in step number 1, negative 24 plus a negative 24 does not eliminate my variable. So instead, I need to now subtract. Subtracting here will create a double negative, which will eliminate my, there's a glare, which will eliminate my y's. So here I am going to subtract, 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 and subtract. Dotted line for balance. 20 minus 36 is negative 16x. Negative 28 minus a positive 60 is a negative 88z. Positive 28 minus a negative 204 is 232. I am going to be honest, I am a little bit uncomfortable with the size of these numbers, but it's okay. Let's keep working. My second thinking bubble, again, I am noticing these are all even, so yes, you can simplify these. Next, I'm going to take my two thinking bubbles, and I'm going to write them on top of each other. So I have 38x minus 46z equals 214. Negative 16x minus 88z is equal to 232. And I am doing a quick check here. What I checked, I'm like, is 16 times 232? It's not. I was hoping it to get that 38 by just multiplying by 2. So 16 times 3 is 48. Nope. And I'm trying to think multiples. 38 times 2 is 76. If I can get 76 divisible by 16, doesn't work. So you have an option here. You can kind of go through your numbers. My choice of variable to eliminate is going to be x. So it is your choice if you want to just go through the motions and find a common number, or if you just want to not do that and just take what the opposite number, take what you see. So for example, I'm going to just multiply this by 16 and this by 38. Yes, this way gives you much larger numbers. We're going to get really big numbers, and that's okay because things will work out at the end. So for example, I got 38 times 16. That is a large number, 608x minus 16 times 4. Doing this on my calculator here. 16 times 46. I get negative 736z. And 214 times 16. 3,424. Again, if you were to simplify these thinking bubbles, you would have smaller numbers. That's why I encourage you to simplify. I just chose not to. 38 times a negative 16, I get a negative 608. Ooh, that's good. This is our goal, is to get matching numbers. Negative 88 times 38. Big numbers. Z. 232 times 38. 8816. Again, very uncomfortable with the size of these numbers. You would not have to deal with this if you did simplify your thinking bubbles. Next, we want to eliminate. Make sure that you are using the correct symbol, the correct operation. So if I add these together, it does give me 0. So I'm going to add here, adding here, and adding here. This will give me 0, negative 736 plus a negative 3344. This gives me a negative 4080z, dotted line for balance. 3424 plus 8816 gives me 12,240. Hopefully this is divisible by a negative 4,080, and it does. Z is equal to negative 3. All of those large numbers, thinking bubble, because this is not our answer, and we end up with a negative 3. Sigh of relief, to be honest, because it was making me slightly uncomfortable. This is the importance of simplifying your thinking bubbles. Okay, remember that this is not your answer. This isn't a thinking bubble because it is important. two things will happen right now. You are going to pick up one of your thinking bubbles. So I'm going to choose this one here just because I have space. I'm going to open it up for my z value. And I'll rewrite this in a darker color here. So what I did with the orange is I just drew an arrow here. And my equation is negative 16x minus 88. I opened up for z. Z is negative 3. When you type this into the calculator, please be careful of what you type in. This is a negative 88 times a negative 3. Negative 88 times a negative 3 gives me a positive number. So negative 16x plus 264 is equal to 232 minus 264 minus 264, 232 minus 264 is negative 32. Bring down the negative 16x. Divide by negative 16. Divide by negative 16 is 2. Again, a thinking bubble because this is not your answer. Now the second thing you're going to do is you're going to pick up one of the original equations. I usually don't think too much about it. I usually just pick up the one that's on top. I'm going to take this one here. I'm going to drag it all the way down. I'm going to copy it so I get 6x plus 8y minus 6z is equal to 62. I do have an x value and I do have a z value. So open up for x, open up for z. We're going to put in our x value of 2. We're going to put in our z value of negative 3. We get 6 times 2, which is 12. Here you have to be careful because you have a negative 6 times a negative 3, which is a positive 18. Okay. Combining like terms, I have a 12 plus 18, which gives me 30. So we get 8y plus 30. Dotted line for balance, 62. Subtract 30 both sides. Now this is an IM1 skill, so we go a little bit faster here. 62 minus 30, I get 32. Divide by 8, divide by 8. Y is then equal to 4. Thinking bubble because this is not your answer. The answer is written in a very specific way. You first have to show that these numbers have a relationship. To show a relationship, you're going to do parentheses. Now that you have your parentheses, you're going to place your commas. Alphabetical order goes X, Y, then Z for our letters. X was 2, Y was 4, Z was negative 3. These little X, Y's, and Z's down at the bottom is unnecessary. You don't need to do this. I am just showing you its order. And our very last question here. Now, on this one here, step 1, 2, 3 is exactly the same thing. I'm going to pick up my top 2, which is 2x minus 2y plus 2z is equal to 12. My next one is 10x minus 2y plus 10z is equal to 60. Now immediately I know that I wish to eliminate my y's because I see them matching. I see that I have a negative 2 and a negative 2. Now again, the plus and minus is okay if you have it. Also, having them completely match with negative negative is also okay. Be careful here on how you choose to eliminate. If you choose to add, that will give you a negative 4, which does not eliminate your y's. Our goal is to eliminate the y's, so I am going to need to not add, but subtract, creating a double negative. So I'm going to be subtracting these, and these terms. Dotted line for balance. Use a calculator, please. 2 minus 10 is a negative 8x. Double check, negative 2 minus a negative 2 does give us 0. That's gone. Positive 2 minus 10 gives me a negative 8z. 12 minus 60 gives me a negative 48. Based off of what happened in my previous example, I am going to simplify this. That was a bit rough with my numbers in the thousands. So I am going to, is 48 an 8. Okay, they do get along. So I'm going to simplify here. And I'm going to divide everything by negative 8. I should have done something similar in the previous example and simplified my thinking bubbles, but again, live and learn. So we get x, careful here, negative negative gives you a positive, z equals, what did I say, 6? I'm going to just write that one more time, just closer together for no reason, just because I want them closer. This is my first thinking bubble. Okay, moving on to my next two terms. So I'm going to take the bottom two, copy them down. Remember, for step number 2, you no longer have a choice. Whatever variable you chose to eliminate in step number 1, you must eliminate in step number 2. Now, as I am writing this, I'm noticing and doing a quick little happy dance because if you notice, I need to eliminate y's, and y's already match. Happy dance. Now, be careful here. Again, our goal is to eliminate. So in the last example, or sorry, in the last step that we did, step number 1, I subtracted negative 2 minus 2. If I do that, it doesn't give me 0. So now I'm going to check negative 2 plus a positive 2. Adding gives me 0. So now instead of subtracting, I will be adding, dotted line for balance, and we're double checking 10 plus 2 is 12. X. These we double checked is 0. 10 plus 2 is 12z. 60 plus 12 is 72. Again, just like I did here, I am going to choose to simplify. Otherwise, we might end up in the same situation. And I know 72 and 12 get along. It doesn't have to be the leading coefficient always. So in the last example, if you wanted to simplify, I believe all of the numbers were even, you could have divided by 2 and made those numbers smaller. It doesn't have to be by the leading term. So then we have x plus z equals 72 divided by 12 is 6. Thinking bubble, here's my second equation. Step number 3, we take our two bubbles, we take our two equations, and we're going to write them on top of each other. X plus z equals 6. And the second one, x plus z equals 6. Now here, please do not make assumptions, okay? Go through the motions. Our step is to choose a variable. I'm going to choose x and then eliminate that variable. Sometimes here, our eyeballs make assumptions, and sometimes those assumptions are not true. So just go through the motions. We got x and x. I am going to subtract, dotted line for balance. X minus x is 0 x's. Z minus z is 0 z's. 6 minus 6 is 0. Nothing plus nothing is 0. And we bring down our 0. This right here is an always true statement. 0 is 0. It will always be 0. So always true. That means we have infinitely many solutions, which means we have dependent answers, which means you have to keep solving. To keep solving, you're going to pick up one of your thinking bubbles. I'm going to use this one just because it's closer. Sometimes they match, sometimes they don't. And we have here x plus z equals 6, and I'm going to choose to solve for one of my variables. Now I am going to choose to solve for x, which means that I am going to subtract, dotted line for balance, z to both sides. X is equal to negative z plus 6, thinking bubble. Now, what does this mean? This means that x is now dependent on z, which means z is our independent variable. Okay, what does that mean? That means I'm going to draw a line here, And I'm going to focus on the three variables that I need to solve for. I need to solve for x, I need to solve for y, I need to solve for z. What do we know about these variables? We know that x is negative z plus 6. We know that z is our independent, which means I'm going to keep it. And y is unknown, so I need to solve for y. I'm going to pick up one of my original equations that is given. So I'll choose again. I usually don't think about this. I just pick the top one. And I'm going to drag that down and I'm going to write that in. So I get 2x minus 2y plus 2z is equal to 12. I'm going to open up for x because I do know what x is. I'm going to keep y because it's unknown. This is what I need to solve for. Plus 2z, and I'm going to keep z because it's our independent variable. Equals 12. I'm going to put in my x value of negative z plus 6. I'm going to distribute, solve for, now be careful here, what's our goal? Our goal is right now to solve for y. So I need to get y alone. Let's go ahead and continue. We get positive times a negative is a negative 2z. Positive times positive is a positive 12 here. Plus 2y plus 2z is equal to 12. Notice what ends up happening, and this does not always happen. It just happened in this example. I get a negative 2z. I get a positive 2z. My z's are gone. I end up having 12 positive plus 2y equals 12. I'm going to subtract 12 both sides. Dotted line for balance. Bring down my positive 2y. That's 0. That looks like 0. Divide by 2. Don't get mixed up here. It's still okay to divide. Y is then equals 0. Thinking bubble. So now we know y is 0. I just have enough space for my final answer. I'm going to write my final answer here. Again, when you write your answers, you must open up your parentheses. This tells me that there is a relationship between your numbers and between your answers. Write them in alphabetical order, so x, y, z. What was x? X was negative z plus 6. What was y? Y was 0. And what was z? Z was kept as z because it is our independent variable. All right, beautiful people, thank you for hanging in there, and good luck on your exit ticket and later your test. Bye.